Good afternoon, all. Thank you for coming. Thank you for staying. So my name is Viv Richards, and in this session, we're going to look at spot the difference, automating visual regression testing. So in this session, we're going to look at why I think manual testing a lot of the times isn't enough. We're going to look at some common issues with UI end-to-end testing, primarily using Selenium. We're going to look at visual testing, what it is, how we can start to look at using it, a lot of the pitfalls that you may encounter in trying it out, and then ways to overcome them. So are there any, can I have a show of hands, are there any cricket fans here today? One or two, that's good. Because apologies if you're expecting anybody else. I'm not the West Indies batsman, and I don't like cricket. So a quick bit about me then. Previously, I was a .NET developer for about 7 years. It's a full stack. I did a bit of testing, a bit of development, design. I'm now a senior test engineer at a company called Viv, based in Swansea in Wales. And I try to keep sort of busy in the community, trying to sort of learn and share knowledge. So I help with Code Club. Is anybody aware of it? Hands, yeah. So Code Club is a fantastic thing that, everybody here should definitely look at. It's a way of sort of teaching the next generation of 9 to 11-year-olds just some basics of code. You don't have to be able to code, but it's a fantastic thing. It's very sort of enjoyable. I'm an organizer of 2 other conferences as well. If you're interested, check them out. So why automate end-to-end UI tests? Well, it can be a lot more reliable because it's being performed by tools. So instead of as humans getting distracted when we're trying to follow scripts, it should execute what we tell it to do. And it should also be as well, depending on sort of your tools and your frameworks, it should be a lot quicker to execute. But there are quite a few issues with UI testing. So the first one is investment is required. And that's not just having money available to just throw at any tool or framework. It's having the time to be able to properly look at what this tool or framework is offering and see if it's the right fit for you. Just because you can do something, you shouldn't just do it. So you should spend some time in actually investigating, is it right for your business? Does it fit into your workflow? If you're trying to get manual testers on board with automation, is it a steep learning curve? Can you support that? And automated testing is only practical when you're doing the same thing over and over again. If you're just doing something that could be just a throwaway type test, then it's not the right sort of option for you. And the most important thing, especially for this talk, is that automated testing doesn't entail human observation. So a lot of the time, as we'll look at shortly, you can test for something that exists, but it may or may not look at how you expect it to. And it can be a bit of a slippery slope as well. So I've seen this quite a few times whereby people, because they can do something, they will, and they want to automate absolutely everything. So just a simple thing like this, trying to pass the salt, someone's off and they're trying to write an automation test just to cover that. And it's not necessary. It's a waste of resource or of people's time. So this, for those who aren't familiar, this is a variation of the test pyramid. So this is the ice cream cone antipattern. And we're going to look at a few antipatterns for the test automation pyramid. And what it's actually showing, for those that don't know, is that the higher you go up through the levels of testing, the slower the tests become. The lower down the testing pyramid, the faster the test should be to execute. Likewise, the lower you are down the pyramid, these tests should be a lot sort of cheaper to implement and maintain, whereas when you go further up through the stack, the tests become quite expensive to implement and maintain. And at the top, you're always going to have this sort of bubble, and this is sort of the manual exploratory testing. Even if you've automated everything, you're still going to want to make sure that you've got some human eyes on it, because even if we, with the best will in the world, we write these tests, we can make mistakes. So this is the hourglass antipattern. So sorry, I briefly brushed over it. This is something that I see quite often. So in my current role and in my previous one, where we've got tests that are taking too long to execute. And the problem is that the teams, they lack lots of unit tests and integration tests. And to try and get around it, what they've done is they've created lots of Selenium UI tests, end-to-end tests. but they're just testing too much. And when I've approached them about this, they've said, well, we're aware we don't have the unit and integration tests, so they want to make sure that things still sort of work. So the test has gone off and written these tests. The problem is they should be having conversations to try and move the tests further down the stack to get that quicker feedback, especially if you're working as part of an agile team and you're working within quick sort of release cycles. You're going to want that quick feedback. You're going to want things to fail so you can quickly adapt. So you have the conversations, and the teams then, they think, well, okay, I'm going to start then getting some more unit tests in. But the problem with this pattern is that even if you had 100% unit test coverage, it's still, there's a problem. Does anybody know what it could be? The clicker's not working properly. So the problem is that even with 100% sort of unit test coverage, if you don't have integration tests all the way through the levels, then how do you know that the units work well together? So you need to have the tests at the various levels just to ensure that things can play nicely together. And it's something I like to call fragile testing. When you're working in an agile team and you need that fast feedback, you need to fail fast and you need to be able to adapt to change. So having tests that take too long to execute and give you that feedback in order for you to know whether or not you can ship that product is not good enough. You can't work like this. Which is where this is, there was a talk earlier, the Cypress.io talk, if anybody went to it. So this is what was touched on then. So this is the ideal sort of testing pyramid or test automation pyramid. So this is showing that you should have more unit tests and then service or integration tests, fewer, but still some to ensure that the units work well together. And then at the very top, you have the UI tests. So you have a lot less of those because they are going to be expensive to implement and to maintain, and they are going to be slower to give you the feedback. Of course, it does depend on the frameworks that you use. Cypress.io talk does mention that they think you should have more UI tests. I haven't used the tool personally, but perhaps that would work in this scenario where you could have the sort of inverted pyramid. I don't know. But you still have this sort of bubble at the top with the manual and exploratory testing. You're always going to have to invest a lot of time to ensure that things still work as expected. So I've already touched on then that UI tests, they do take a while to try and implement and maintain. And also, we've still got this bubble, the manual and exploratory testing. And this allows us to get a lot more feedback. So whilst it may take longer for then a UI test to execute, we're able to actually see if things look how they should. And we don't get that from using tools like Selenium. There's a problem with manual testing alone because it's time intensive. Again, we're humans, we make mistakes, we get distracted. If you work as part of an agile team, there seems to be meetings every other minute whereby you have to go to a stand-up, there's a planning, refinement, lots of different meetings all the time. So it's easy to get distracted and you've got to put something down, context switch, and then come back. And it's just difficult. And it's time-consuming as well because while you're manually trying to test something, that's taking you away from, if you had an automated test just to automate the right bits of the system, then that could be running off while you then do your exploratory testing or running through your scripts as you need to. And it's only practical when you need to run over the tests more than once or twice. It's a problem that I've seen quite often. So even with the best intentions in the world, and you get something like Selenium. So I'm going to talk a lot about Selenium today. Even when you create a lovely framework for your team to get on board, and you create all these helpers and things to try and get people on board to write more automation for UI tests, it's still a struggle because, especially for us, because we work in 2-week iterations, people don't have time to stop to try out new things. They're constantly trying to sort of release products at a pace. And so even if you give them the wheels for the cart, they just can't stop because they don't have the time. And the problem is, they don't automate because they don't have time, but they don't have time because they don't automate, and they need to try and break that cycle. So it's a bit of a catch-22, and this is where we've been looking at sort of, you've touched on session before last, pair programming and things like that to try and get testers to work with developers to try and find value and try and get some tests, to try and break the cycle, try and get some happy path tests in, just to try and free up some time so then manual testers can go in and test, run through the scripts, do some exploratory testing, just to try and help. But the problem is when you start looking at test automation, there's just so many options. So again, we use Selenium, but it really depends on sort of the operating system that you use. It depends on the language. So if you're looking to implement a UI test framework, what are your developers using? Are you going to try and use something different? Are you that comfortable in sort of writing code? If not, you're probably going to want to stay with a language that your team are using, so you can get that support, you compare on things, and you can do that knowledge transfer. Browser support. So some of these say, Selendroid, that's aimed at Android. So are you targeting mobile devices, web devices? Visual Studio, coded UI. So perhaps you can't write code, so you want to just be able to record, run through an application, record the steps, play them back as part of your CI. But then with that tool, you can only then execute your tests in Internet Explorer. So then you have to think, well, what are my customers using, the browsers? Do I need to support IE, Chrome, Firefox, Safari? What other ones are there? So it comes to cost as well. So not all of these are free. And again, it's not just cost of purchasing something. It's time that you're going to need to be able to look at something and implement it. There's one on there. Appium, has anybody used that at all? A couple of hands. So this is something that I've recently started looking at. So this allows us to, so we use Selenium to write our code for our tests, but with Appium, it's free, you can install it, and it runs as a server, and you can point your tests, the same Selenium C# code, at the Appium server, and all of a sudden you can start then running your tests in iOS, Android. So there are lots of tools that help you extend Selenium, if that's the tool of your choice, or the framework. So for us, it was a popular choice amongst the team because it's open source, so we can see exactly what the code is doing. If we want to do a pull request or we want to make some changes, we can. There's a big community of support as well, so if we get stuck with something or the developers don't have time to support testers, then they can go online, they can go on GitHub, they can check out, try and get some support. You can operate on almost any operating system. The main thing for us is the multiple language support. So as I've said, we use .NET, C#, and Selenium. I've probably missed some languages off there, but there's such a wide range of language support. And for us, again, the support of browsers. So for our customers, we have to be able to run our tests or UI tests in Chrome, Firefox, and IE, and ensure that whatever the browser of choice for our customer is, that the test will execute and pass. Something to be aware of, though, if you do go with something like Selenium and you start to look at creating lots of helpers and things for your framework, you will lose some of these benefits because you're going to lack getting some support from the community if you start building your own helpers or the way in which you implement or interact with something changes from actually the core part of Selenium. And it's not a silver bullet either. What we try to do is, so we're trying to push the tests down to the lowest stack possible, so we're trying to get more unit tests. Whilst testers perhaps don't always have the coding abilities to write the unit tests, they tend to have a lot more domain knowledge of the business. And so we pair testers with developers, and we start looking at other ways in which we can add value for the unit tests, looking at boundary checks and different things to try and increase coverage at the unit level. And then for the UI test at the very top, then, we're just trying to look at happy paths and critical paths through the system. So beware, as we'll find out, it can be slow, it can be quite difficult to maintain, so use it wisely. The browser compatibility issues. Perhaps not everybody would have these issues, but because we try to support Chrome, Firefox, and IE, the speed in which tests execute, so the same test that we run and we point at a different web driver, the browsers or the drivers will actually execute at a different speed. And so all of a sudden you find yourself within your tests having to do wait for this to happen or retry until this happens. So all of a sudden, your tests become quite bloated because you're trying to sort of wait for various differences within browsers. And another thing, not so much a problem for just UI testing, but when we start to look at visual testing, the way in which they render differently does cause a problem when you start looking at visual testing because browsers will add certain padding and render things slightly differently. Execution speeds. Again, if you use Selenium for UI testing, I've seen a happy path test through a system take up to 15 minutes. I've been aware of situations whereby somebody's had those types of tests run for lots of different journeys. It takes up to 4 hours before they know whether or not all the UI tests are passed. And if you're coming up to regression day and you're waiting for all those tests to pass before anybody can jump in and manually test and run through scripts, it's just too long. You need quicker feedback so you know you can gain a bit of confidence in the software before you ship it. So yeah, maintainability. As I've touched on, your code will become messy when you start to take account for different browsers, when you're waiting for things and you're checking things. And depending on the browser that you're working with as well, you'll find that the code which you write, in which you're going to try and interact with different elements on the page, it will differ slightly as well, depending on the browser you use. So for example, if you were using IE and you wanted to sort of input something into a text box and then click the send button, you may have to do a send keys.enter. For Chrome, you may have to do a find element by ID.click. And so things do differ. So all of a sudden, again, you start having to write checks in your test code to say, if you're using this driver type, then do this. If doing this, this driver type, do this. And you can see how your code base, just for your tests, start to grow and grow and grow. And all of a sudden, it becomes quite unmanageable. So this is just a sort of dummy contact form knocked up. And I wanted to ask, how valuable do you think these tests are? Apart from end-to-end functional tests in your system, if you were to write the test that purely just checks the text on a page, does anybody think that this is too much? Or is it not enough? Should we do it any more? Okay, so what's that, sorry? Yeah, so you could start looking at fill-in text. Hopefully, though, when it comes to sort of end-to-end tests, for the happy path, perhaps users would have been sort of inputting text just to get a flow. But I've seen scenarios whereby someone will create a UI test suite. They'll create the end-to-end test. They'll input all the text. But then they'll have additional tests which just do this, where they just check text. And again, that could be done at a different sort of level. And the problem with this is I've seen teams relying on tests like this in production. So all of a sudden the tests run and what's gone on? So there was something happened in support whereby a customer called up and said, our customer is no longer able to navigate through the application and submit the form. So the support person went to the DevOps team, they checked the Team City build, they checked all the tests, see if they passed. All the tests are passed. The problem is that the Selenium tests, they checked, were these elements somewhere on the DOM? They didn't check where they were. And what had happened was there was a CSS breaking change. The test rightly so passed because they could find the element somewhere, but it was in the wrong place and it was hidden behind another element, so the customer could no longer progress through the journey. So this was quite a big issue for us, and this is what sort of led us on now to look at the visual testing. So when it comes to UI testing, there are a few things that you can try to do to try and make your test less flaky. I'm not going to try and explain better than Martin Fowler, but it's a really good blog post if you're interested to find more. It's basically, for those that don't know, if you're trying to, it's going to help with maintainability. If you find the way in which you interact with an element on a page, you're doing that in more than 1 or 2 tests, you'll want to extract that element out into a page help object. So if an ID or something changes for that element in the way in which you interact with it, you just change it in the one place, and then everything is sort of more easy to maintain and helps with things if you look at kiss and dries or keeping it simple, not repeating yourself in your code. Another thing, so is anybody familiar with QA selectors? Perhaps you call them data QA selectors. So this is a really good thing. Using the contact form example again. So the code at the top is sort of the typical sort of markup we see for some of our journeys. But what you can do is, to try and make your test less flaky, for example, the submit button, for the class of it, we can say, we're going to give this a unique class of QA-button-cancel, and for the submit, for the submit, QA-button-submit. And what this allows us to do is, we know that when we write our tests, we're always going to be writing find element by CSS selector, so our tests become clean in which we interact with an element. So it's easy for people to get on board, because they don't have to worry about helpers and things. They just find the element in that way. It helps with, if you've got front-end developers who are making lots of changes all the time, when they get to the page and they start to see classes with QA selectors on, they can see that you've implemented UI tests that are relying on those elements. So they're less likely to make breaking changes, more likely to have conversations with you to see how you're actually using that button or that control. So it's really good. This is something that on the team, we, as testers, we will actually go in and change the views. I appreciate not everybody is comfortable in doing that, but again, this is an opportunity to work within your teams. It shouldn't just be developers and testers. We're all trying to deliver a quality product, and it's all about knowledge sharing and releasing something together. So it's an ideal opportunity to pair and gain some new knowledge. So I wanted to find out how good you all are at spot a difference. What we're going to have is 30 seconds. There are going to be some differences on the right compared to the left, and I want you all to see how many differences you can find. Okay, time's up. So, could I have a raise of hands? Did anybody find 2 or 3? Keep your hands up a second, sorry. If you didn't find 4, put your hand down. If you didn't find 5, put your hand down. 6. Okay. So, there were 8. I appreciate it's probably quite difficult to see from at the back. But the problem is, we didn't have a lot of time there, and how do you know when to stop? There were 8 differences, 4 of these, so if we go through them from the top, there's a WeAreDevelopers logo. Using sort of standard Selenium UI tests, we wouldn't have found that. We wouldn't pick up that the image is different. FAQs, if we had used the approach I showed previously, we would have found the text change. Speakers, we would have found the text change. Steve's change of companies, we wouldn't have found that. Trello, we would have found the text. Ethereum, we would have found the double quotes. But we wouldn't have found the Twitter handle moving either with the padding. Oh, sorry, and there's padding at the top as well. So 4 of these changes we would have found, 4 we wouldn't have. And like I've said, how do you know when enough is enough? When you're trying to release software fast as part of an agile team, it's difficult. And you need to sort of, test never finishes, but there has to be a point where you say, well, enough is enough, and it's difficult. So how can we then add more value to the top? So if we look at our UI, manual exploratory testing, what if we could simply say, well, I have this base image on the left, so I know this is how this page should look. And then I want to see if, when I launch my web driver and take a snapshot, whether or not that matches our base image. So when it comes to visual testing, there's a lot more options out there than this. But these are just a few that sort of I'm familiar with. And again, it depends on sort of what you're looking for. So whether or not you have money to throw at things. So Phantom CSS, Wrath, and Bootstrap, they're free. They're open source on GitHub. But what they require you to do, so Phantom CSS, Wrath, and Backstop.js, you have to write your test in JavaScript. Wrath is actually maintained by BBC, if anybody knows of them. Percy, they have a free plan, but then, so Percy is $150 a month then for 5 users. So it gets expensive. So as you start to scale up and you start to write more tests, it could become quite expensive. Ghost Inspector, so that's free, but again, after so many comparisons, it's not free, and it's going to be quite difficult for you then to keep writing those types of tests, and it's going to be difficult to try and sell to your business unless you've written enough tests to prove its value. One I really like, though, is Apply Tools. So this isn't free at all, but what Apply Tools is I think they use AI, so it's a totally different approach to what I'm going to show today, but they allow you to do things that I haven't seen before. So imagine you had 2 Twitter streams, but the ordering of the tweets differed slightly, but the content was the same. They can detect that. You don't have to write code. You can write code, but they have a nice GUI where you can sort of drag over areas of interest. They can ignore dynamic bits of the page. They can look at layouts only, colors only, text only. It's just really powerful. But again, it's paid for. And it's one of those things. Visual testing may not be for everybody, but if I could sort of give you any advice, it would be look at some of the free ones, see what it offers, see if it works for you. Perhaps it won't. It's not going to be for everybody, but it's definitely something you can look at to try and enhance the quality of your software. So for us, the issues were quite a few, really. They didn't work straight out of the box. As with any sort of tool or framework, you will get sort of bloat. There's a steep learning curve. So we have probably 3 comfortable test automation engineers with maybe about 11 manual testers who are trying to move into automation, but they've never written any code. So trying to get people on board with a new way of doing something is quite difficult. So for us, it was important that we still use C# and .NET. It needs to be able to use our helpers that we've already created, and it needs to be something that we can just sort of bolt on top and just work. Small community or lack of support, so that was a difficult one for us. Some of these things are quite new, or they've been around for a while, and people have sort of hit various snags that we'll come to in a minute, and they've just thrown the project in the bin. Costs, again, yeah, like I touched on, so depending on sort of your costs, there'll be time for people, or perhaps you won't have money if you're a startup, so you need to keep that in mind as well. And one thing I haven't put on there is some of these frameworks, they actually put your images on the cloud, so it's not local, and perhaps you need control over these images, so it's not going to be ideal in that scenario. So it's been a year. It's mainly just been me sort of developing this framework. And a lot of the challenges, to be fair, have been because of the way in which we've implemented our software. So to give you an example, the reason why we have trouble writing our Selenium UI test is because, for some reason, our IDs for our elements, they're generated, so we can never guarantee that our IDs are actually going to be unique, which is a problem. So perhaps you want to have some of these issues, but we'll have a look through now. So reliability. Like I mentioned earlier, browsers render slightly differently. So you will get certain differences. So this is an image on the left-hand side of a Google WebDriver that's opened at a Google homepage. And then we've stored that image, launched a Firefox WebDriver, taken a snapshot, and then done a byte-for-byte comparison based on the image, and found all these differences, even though the page was as expected. Execution speed. So in creating the framework, we want to see how quick it was. So this is comparing a base image, opening up a WebDriver window, taking a snapshot, comparing. And that was 4 seconds. So it's important to keep in mind as well, though. So whilst that is quite quick, and we'll see even quicker tests in it shortly, you're still, because this technique or this approach is used in Selenium, if you have an application whereby you have to, so for us, we have a customer, which is our customer, and then we have their customers. So for each of our tests, we have to open a WebDriver window. So we'll just call them customer or main customer and their customer. We have to open 2 WebDrivers. The main customer has to log in. They have to generate the code. They then have to send it to the they're a customer, then they have to use the code and log in. And you have to do that before you could even do the comparison. So you're still going to have that sort of heavy lifting to get to the point where the pages are at a point where you actually want to take the snapshot and compare them. So you're still going to have that. So I thought we'd play another game. It's 3:45. I want to try and keep everybody awake. So we wanted to see just how quick this visual approach could be. So on the right-hand side, you're going to see, hopefully, where's Wally. On the left-hand side, there should be no Wally. So have a look and see how quick you can find him. Yeah. And these are the two exact images we give the framework as well. Would you like me to zoom in a little bit for the back? A little bit more, maybe? Anybody? Yeah, a few. Excellent. So there he was. So the point is this, is that when you have lots of things going on, it can be quite difficult to find, the smallest of details. How quick was the machine? So 293 milliseconds, based off those two images. And so this is the code to do it. I will, at the end, there's a link. It's very rough and ready, but if you want to sort of play around with this idea, it's something I've sort of cobbled together. You can download it. At the bottom, this is an image that's created. So when it does find differences, and you run it in Visual Studio, it will output to say it's failed. It'll tell you where it's created the image, and then what it'll do is it'll draw pink boxes over the original image to show you where the difference was. So you can quickly find out what the issues were and pinpoint them. Maintainability. So again, this is quite difficult to try and maintain when you start taking account for waiting for various things to load, looking at different driver types. So it can be quite a pain. And if you imagine doing this for lots of different screens of your application, and then you think, well, that's just for one customer, and then you've got all their screens, it can start to build up and up. So what you can start doing is, so the top bit of code, all the value that was doing was just confirming text. Using the visual framework, what we're actually getting now, all of a sudden, from less lines of code, we're checking all the text, checking colors, we're checking padding, we're checking everything. And this is a really good thing. So we work with lots of customers from lots of different countries. So when you want, perhaps, you're dealing with, for example, a Portuguese customer that we've dealt with quite recently, and it's very easy to sort of gloss over something and think it looks about right. But when you're not comfortable with that language, it's easy to make mistakes and sort of just gloss over things. So maintainability, this not only does it give you sort of more value, I feel, from this type of test, if you're going to implement this type of test, it's less lines of code, so it's a lot easier to maintain. You can take it further. So don't judge me, there's a few Specflow people here. So this is Specflow, and can I have a raise of hands? Is there anybody who's used Specflow? Couple. Okay, so Specflow is an open source port of Cucumber for .NET. So what you can do is, for us, we've got, we work as part of an agile team, and when we come to define our user stories, we have, given I do this, given I'm here, when I do this, then this should happen. So we write them as a team, and then you can just paste those into something called a scenario. And what these scenarios then do, or allow you to do, is to generate step files. So the code at the bottom are steps that are generated from the scenarios. And this is really powerful when you start looking at the visual testing stuff, because this, no matter how many different scenarios that we implement here for our different types of pages that we're going to visually test, it's the same code because we're using parameters to pass into the same two stubs what we're doing. So we could have hundreds of these different scenarios, checking all of our pages of our application, but this is the only code that we'd ever need to run through and compare all the pages. You could take this further with scenario outline, I think it is. So what you can do is you can, instead of spitting out lots of different scenarios, you can have a scenario outline where you just have the one scenario and you have a data table, and then you can just feed in from this data table all your URLs and all your base images. So you can really keep it easy to maintain, and you can fire all your sort of base images and URLs at it, and quickly you can check, do they look as expected? So, like I touched on again, this is a Google homepage snapshot taken, but it was actually taken in the same WebDriver. But the reason that this has failed is because it was an animated Google homepage. So things like this can catch you out, and we'll look at how to sort of get around that in a second. Accuracy, so it can be pixel perfect. So previously I showed a slide where it showed some of the visual testing frameworks. Not all of them claim to be pixel perfect, but they say it's good to that human eye or something like that, so it's what the human eye can see. So I'll touch on it shortly, but there will be various issues when you start running comparisons on your machine. You check it in, and then a team member runs the tests, and there's ways to get around that, which we'll look at shortly. Image quality difference, so there is none. The reason being, as long as you run the test on the same hardware, it doesn't matter. It's the same WebDriver that's taking the images that it's going to do the comparison with. So what we've done, we've got, or what you can do is you can create config files for your test, and you can say, well, this is the browser sort of height and width for this type of device, a tablet, screen. And you can start taking base images of the different responsive type sites, and then you can do comparisons at that level. So there's been quite a few challenges, and some of these are, if you look online about visual testing, this is what you'll come up against, and hopefully these ways to overcome them you can sort of apply to any visual testing framework. So originally we thought we could just have a base image for a website, but you can't. Because of the way that different browsers render things, you have to have, so again we have to support Chrome IE and Firefox, we have to maintain base images for each of these different browser types. So for the Google homepage, for instance, we'd have to have a base image, or 3 of them, for each of the driver types. You can change the code so it can detect which driver that you're running it in, and you can get it to automatically create the base image for you. If it doesn't exist, obviously you don't want to start overwriting the base image if there's been no change. Screenshots. So a lot of the frameworks, they'll just give you the, in the top left-hand corner, it's the viewport, so what the WebDriver can see. And it's this way on purpose because it's a W3C standard. But what you can do is, with Selenium in particular, is you can inject JavaScript. So what we've done is we've detected the height of the page, and then we get it to inject JavaScript to scroll down, and we stitch the page together so we can get a full page screenshot. Something that's really good as well is that you can, I think quite a few of the other frameworks do this, you can get down to an element level by specifying an ID or class. So this is quite handy for a few things. So if you think that you're dealing with something like WordPress or a dynamic-driven website where things are changing all the time, you don't have to sort of do a full-page comparison. You can just look for the header. Or if you work for a customer and different customers have different branding, you can get down to the input, like the button level, and you can just check quickly, do all the buttons look the same, do the headers look the same, and that sort of thing. So it's really, really good. So this caught me out quite a bit. When I first started developing the framework, I ran to the retro to try the review to try and show off the framework I'd developed, and it didn't work. All my tests failed. And the reason was, so this is how it should be done. The reason was why it didn't work was because when I launched the WebDriver, I was maximizing the window. And the problem is, depending on the screen size or display size, the WebDriver window will sort of fill. And when I remoted into the computer, it was a different size to actually my machine. So a way to get around that, or what you should do for your test, is just specify a height and width for your WebDriver window. Don't ever maximize it, and that way you're not going to have issues if you start to look at visual testing. Responsive design again, so you can specify in sort of configuration files different sizes that you want to test, but beware if you start to take lots of base images at all these different sizes for all these different browser types, it's going to become quite a manual process all of a sudden because you're going to have to maintain these base images. You're going to, if you had a Google homepage and you had base images for these 4, it may work on 3 and fail on 1, and you're going to have to go in and manually check the diff images to see what's different. And this could be quite a problem if you've got quite a large application with lots of screens. Hardware issues. So I touched on that. It can be pixel perfect. So if you aren't using the exact same hardware as your other colleague, then you will run into issues because the hardware, you'll start to get anti-aliasing issues. So you'll find that one computer will start to, I don't know, the way that it tries to sort of render something smoothly would be slightly different on one machine to another. So it may be difficult to a human eye to see the difference. When you start looking at pixel-to-pixel differences, it will detect it, and it'll say that it's failed, even though it looks fine to the human eye. So this is where you can start to then, you can apply a tolerance. So when you run your tests and it creates the base image, the difference image, you can either get the image where it draws the pink boxes, or you can get it to draw how much that pixel box differed. So this is really good because when you create the base image and you get that image where it says it differed by 15 pixels in this bit, 20 in this bit, 25 in this bit, you just take the max number and you know that that's the tolerance level you need in order to run your tests and pass them same as your colleague. It doesn't really devalue the test because some of the differences that it'll pick up, they'll be difficult to see to a human eye. So we've got a tolerance set of 20 for all of us, for all our tests to run, and it can still pick up a single text change. So if you've got text that's 16px, for argument's sake, it can pick up if you've got a slight difference in characters. There's lots of other ways you can get around this as well. You can look at creating like a service whereby you take the snapshot, you send it off to the service to do the comparison, and it returns it back. So you've got one source of truth that's actually doing all the sort of the grunt work. Other people have said you can use Docker. I haven't tried this myself, but you can get one machine to take all the snapshots and do the comparison. So then you know that the hardware's always going to be the same on that machine. Resolutions as well. If you've got different, like if you've got a 4K monitor and your colleague hasn't, again, you're going to start getting issues. So there's all these sort of things to be aware of. And this is the biggest issue you'll see online if you start looking at visual testing. And I don't believe anybody is 100% pixel perfect. I may be wrong. If you find out, tweet me, because I'd love to know myself. But tolerances is definitely a way to sort of try to overcome some of these issues. Storage. Again, I touched on this briefly, and I'm running out of time, so I'll speed up a bit. If you start trying to account for lots of different device sizes, lots of driver type sizes, storage, you're going to start running out. So be mindful of sort of what browsers you're going to start to, visually test. Dynamic content. So this was quite challenging for us. The way that we get around it is that we basically just blanket over elements. So we identify where the elements exist. So we get their X and Y coordinates, and we simply just block a big bit of color over the dynamic content, and then we take the snapshot. So every time we run the tests, the same thing applies. It'll basically blanket over the dynamic content. And that way, it doesn't matter whether the number of members change for that meetup. We know that the rest of the page should look as expected. Like the Google homepage, if you've got things that move around a lot, what you can do is you can, using the web driver again, you can inject JavaScript. So you can say, stop all CSS3 transitions, stop all HTML5 videos. And you'll want to do that in sort of your startup of your tests to ensure that things don't all stop before you take your snapshots. Otherwise, you're going to get a lot of failures. And again, if you're writing lots of tests for lots of different pages, it's going to be quite time-consuming to run through them all. And for us, one of the main benefits is we use something called Aspos. They do a free trial, but it's quite expensive. You have to buy it. And we get, at the end of a journey for our customer, they have to sign, and then they get to download a massive PDF document. So what we can do using Aspos is we can say, give me this page, or give me all of the pages, and convert them into images, and all of a sudden we can compare those images against the base images. So if a customer has a new version of a document, and they've changed something because of GDPR or something like that, quickly we can just get all those pages into images, run them through the image comparison, and see what's changed, so we can get a quick view of exactly what's differed. PDF dynamic content. Again, what you can do is you can using Aspos regex. You can find an element by text. So, for example, dates. You can find an element, and then you can just sort of blanket over it or change it. I'm running out of time, sorry. So these are some of the challenges. I'll share the slides later. Just quickly, this isn't the answer to making all your tests fantastic or to replace anything, but it could just be another tool to your tool belt. So just take a look at it. It may not be for you, but it's definitely something that I think you should take a look at. Thank you.